Hello everyone, I am Sanika Ravunकर and today I will be giving you information about one of the most powerful boosting algorithm in machine learning, that is AdaBoost concept and math. So let's get started. So why we need AdaBoost? AdaBoost is a method that takes weak models and makes them stronger. Think about traditional ML models like decision terms. They are weak learners, usually don't perform well on complex data. The main goal of AdaBoost is to boost weak learners into strong learners. AdaBoost improve accuracy of model by focusing on hard samples and combining many weak learners. Now let's take practical example. In face detection, one weak model might only detect the eyes, another might only detect the mouth shadow. Alone they are not enough. But AdaBoost combines many such weak learners, and what's special is it pays extra attention to hard to classify example. Together, these weak learners form a strong and accurate model for face detection. This is the basis of Viola-Jones algorithm for real-time face detection in cameras. So, what exactly is AdaBoost? AdaBoost, short for Adaptive Boosting, is an ensemble learning method. It works by combining multiple weak classifiers into a strong classifier. The trick is assign weights to training samples. Misclassified sample get higher weight in the next round. So the next learner focuses more on misclassified samples. Final model is based on weighted majority vote of all weak learners. Is calculated as h of x is equal to sine of summation of alpha t into ht of x, where alpha t is a weight of weak learner and ht of x is equal to weak learner. Now let's see real-time example of face detection. Weak learner 1 detects dark eyes. Weak learner 2 detects a bright forehead. Weak learner 3 detects a mouth shadow. Individually these are weak, but together AdaBoost combines them into a strong face classifier, and this is exactly what is used in the Viola-Jones face detection algorithm in cameras. Now let's see a diagram to understand better. Imagine you are building a system to sort object. Weak learner 1 makes a mistake and the misclassified red dot is circled. That point is given more weight and appears larger in the weighted dataset. Next, next weak learner that is weak learner 2 is trained on this weighted data and focuses on the previous mistake. Finally, all weak learners are combined using a weighted majority vote, that is strong learner. So, how does AdaBoost actually work? Let's go step by step. First step is a start. Assign equal weights to all training samples. Next step is a train weak learner. Train a simple classifier like decision stump or decision tree on this weighted dataset. Compute its error rate on the weighted data. Let's see step number 3. Compute classifier weight. Compute the error of this learner and calculate its weight, that is alpha t, using formula of alpha is equal to 1 by 2 into log of 1 minus epsilon divided by epsilon. Step number 4. Update sample weights. Increase the weights of misclassified sample so that the next learner focuses more on this hard example. Also decrease weight of correctly classified examples. Normalize weights so they sum to 1. Step number 5. Repeat. Train the next week learner on the updated weights. Continue for many rounds, that is T iterations. Last step is a final strong classifier, that is combine. Finally, combine all the learners with their weights by using Formula h of x is equal to sine of summation of alpha t into ht of x. The result is a strong classifier with high accuracy. Of course, no algorithm is perfect. AdaBoost has some challenges. Let's see challenges and limitations of AdaBoost. First is sensitive to noisy data and outliers. It is sensitive to noise and outliers because misclassified points keep it getting higher weights. Second is overfitting risk, especially if you use very complex learner instead of simple ones. Therefore, sometimes AdaBoost algorithm overfit. Poor performance on imbalanced data. Minority classes often get misclassified unless we adjust the class weights. Last is computational cost. And finally, it has computational cost since it works sequentially. It can be slow for very large dataset. Let's see real-time example of spam detection. If the dataset has mislabeled emails, AdaBoost will keep increasing their weights. The weak learners will try to fix them, but this may cause the model to overfit and wrongly classify many genuine email as spam. So, last of the presentation, what did we learn? AdaBoost is a method that combines many weak learners to create the strong and reliable model. It focuses on hard to classify examples, giving more weight to better performing learners. Focuses on difficult samples at each iteration. This makes it powerful for tasks like face detection, spam filtering, fraud detection, and customer behavioring pattern. Looking ahead, AdaBoost has some existing future trends. Integration with deep learning for hybrid model. Second is improved robustness to noisy and imbalanced data. Third is faster training methods for very large datasets. Application in real-time AI system like autonomous vehicles and smart cameras. And combining AdaBoost with other ensemble methods for even higher accuracy and better performance of the model. Thank you.